Solving a two-step inequality. If you recall from when we did two-step equations, we call this SAD-ME-P. That is the reverse order of operations. And then we do the opposite of what we see. That's called inverse operations. So to solve this inequality, we would do exactly the same thing. So it says 3x plus 4 is greater than or equal to 16. Again, we want to go in the reverse order of operations and do inverse operations. So we want to do subtraction or addition first. Since it says 3x plus 4, we want to do the opposite of adding 4, which is subtracting 4. The 4 and the positive 4 will cross off because they are opposites. Whatever we do to one side, we must also do to the other. So we subtract 4 from both sides. And 16 minus 4 is 12. There was no reason to flip the sign of my inequality because I did not multiply or divide by a negative number. So I will bring it straight down. And I will bring my 3x down as well. Now we move on to division or multiplication. The opposite of multiplying 3 times x would be to divide by 3. And we're going to do that on both sides. 3 divided by 3 equals 1, so they cross off and equal 1x, or just x. We did not multiply or divide by a negative. It was a positive we divided by, so my sign will not flip. I bring it straight down, and 12 divided by 3 is 4. Now, like before, we will need to be able to identify the correct graph of this. And because of the equal bar that is on here, you would see a closed circle on 4. And because x is great, x is big, the big numbers are to the right, so our arrow would be going to the right, a closed dot to the right. It says positive 5 plus 4x is less than 33. Again, we want to use SAD-ME-P, or the reverse order of operations, to solve our inequality. So we're going to look first for subtraction or addition. We actually want to take care of this 5. And it is a positive 5 being added to 4x. So we're going to do the opposite of that, which is to subtract 5 from both sides. And you will recall that we had problems like this when we did equations as well. Positive 5 and negative 5 are opposites, so they cross off. I will bring my 4x straight down. We did not multiply or divide by a negative, so my sign will stay the same. And 33 minus 5 is 28. Then we move on to take care of this multiplying by 4. The opposite of multiplying by 4 is to divide by 4, and we're going to do that on both sides. 4 divided by 4 equals 1, so we're left with x. We did not multiply or divide by a negative. We divided by a positive, so our sign's going to drop straight down. 28 divided by 4 is 7. Okay, that brings you up to example A. It says 7 minus 2x is greater than 11. Now, there is a couple things I want you to notice right away before we start using SAD-ME-P to solve this. Take a look at that minus sign and look where it is. Remember, every term in an equation or inequality has one sign, and that sign is to its left. That sign is to its left, which means that negative sign, that minus sign, goes with the 2 that is attached to the x. So that's negative 2 times x. Think back to when we just did one-step inequalities with multiplication and division. We determined that if you had a negative coefficient, like this negative 2, that you would end up flipping the sign of the inequality in your answer. So this is going to be one of those cases where we are going to end up flipping our sign. We're not going to do it right this second, although we can come down here to where our answer might appear. And to remember that, and this will be helpful when you're taking checkups and tests in the computer, to go ahead and put that sign in reverse, because it is going to happen when we do this problem. Then the second thing to realize is then that makes this 7 not -7, it's still a positive 7. So when we start doing this SAD-MEP, this reverse order of operations, we need to do the opposite of a positive 7 or a plus 7, which is -7. This is sometimes tricky for students. So make sure that you are subtracting 7 on this problem, because this 7 is positive. It is positive. Positive 7 and negative 7, being opposites, will cross off, and notice that leaves you with negative 2x. It is still greater than, because we have not multiplied or divided by a negative yet, 4. 11 minus 7 is 4. Now we got to do the opposite of multiplying by negative 2, which is dividing by negative 2. This is where dividing by negative 2 causes my sign to change directions and flip. Negative 2 divided by negative 2 equals a positive 1x, and then positive 4 divided by negative 2 equals negative 2. So we end up with an answer of x is less than negative 2. Take a look at example 4. X divided by 2 minus 5 is less than negative 8. So now that it's come back up, we probably should say, is this going to be a flip or no flip? Well, notice this time the minus is with the constant. It is with minus 5. Over here where our coefficient is, it's positive. This is going to be a no flip. So when we're done with this problem, it will still be a less than symbol. Doing SAD-MEP, we want to make sure that we take care of addition and subtraction first. The opposite of subtracting 5 is adding 5. So we're going to add 5 on both sides of our inequality. Negative 5 and positive 5 will cross off, leaving you with x divided by 2. We drop down our less than symbol, and negative 8 and positive 5 being different signs, we'll do the subtraction and take the sign of the bigger looking negative 8, making that a negative 3. Now we will do the opposite of adding or multiplying or dividing. The opposite of dividing by 2 is to multiply by 2, and we will do that on both sides. A positive 2 and positive 2 cross off, leaving you with positive 1, and negative 3 times positive 2 equals negative 6. And again, notice because we multiplied by a positive number on both sides, our sign did not flip. Let's take a look at our word problem. Halfway through the bowling league season, Stuart has 34 strikes. He averages 2 strikes per game. Write and solve an inequality to find how many more games it will take for Stuart to have at least 61 strikes, the league record. Interpret the solution. Again, like we've been doing through the entire chapter, we're going to ask ourselves, what are we trying to find? It says, find how many games it will take for Stuart to have at least 61 strikes. So it's how many more games is what we're trying to find. How many more games? So we're going to let G equal additional games. We know he's already played some games because it says how many more. All right, it says halfway through the bowling league season, Stuart has 34 strikes. He averages 2 strikes per game, and he wants to have at least 61 strikes. So we have 3 facts in our problem. We need to ask ourselves, is one of those my total? Now, this could be challenging because it says halfway through the bowling season, Stewart has 34 strikes. At first, that sounds like that's probably our total. But then when we get down to here and it says, how long will it take for him to have at least 61 strikes? Well, they both kind of sound like a total, don't they? The key here is that where it says Stewart has 34 strikes, that means that's already occurred. That's not what we're trying to get to. So it's actually down here. He wants to have at least 61 strikes. That is our total. So again, totals go by themselves on one side of our equal or inequality sign. And because it says at least 61 strikes, we know that this is a inequality. The question is 61 the smallest or 61 the biggest? Because that's going to determine the direction of our inequality sign. Because it is at least 61, that is the smallest number of strikes that Stewart wants to have. So the alligator needs to be turning its back on that because that's the smallest number. Now, is he going to be okay if he gets just 61 strikes? Well, yes, it says at least 61. So that means 61 or more is what he wants. So we can include the equal bar on this problem. Now we've got to determine what are these other 2 facts. One of them has to be a coefficient being multiplied by our variable, and then one of them needs to be a constant. So it says Stewart has 34 strikes. That sounds like something that has already occurred, and it is a one-time event. A one-time event. That makes that a constant. So we're going to add that to our variable. Then it says he averages 2 strikes per game. That's right there indicates the word per, indicates that this is going to be a coefficient where we multiply our number of strikes times our number of games. So strikes per game. So we're going to put our 2 times G plus 34 is greater than or equal to 61. Then we would solve it. Using SADMEP again, we're going to take care of addition and subtraction first by subtracting 34 from both sides of the inequality. Positive 34 and negative 34 are opposites and cross off, leaving you with a positive 2G is greater than or equal to 61 minus 34, which is 5. Make that an 11. 11 minus 4 is 7. 5 minus 3 is 2, equals 27. Then we're going to ask ourselves, do we flip or no flip when we go to multiplication and division? And because 2 is positive, we are not going to flip our sign. We are going to do the opposite of multiplying by 2, which is to divide by 2. 2 divided by 2 is 1, leaving with G. And then 27 divided by 2, that's not going to come out evenly. It comes out to be 13 and a half. So we need to interpret this solution because it says, how many more games will it take Stewart to have at least 61 strikes? Can he get 61 strikes in 13 games? No, he needs to bowl at least 14 games. So we would say Stewart must bowl at least 14 more games.